Good day. My name is Youssef, as already been said, and this is Building Scalable and Resilient Background Jobs for FinTech. Um, quick agenda. So we'll go through a little bit of intro about myself and the company I work for, and then pipelines, the what, why, and how. This is how we use background jobs at the company at PayPal Braintree, and the keys to scale, how we build resilient pipelines and background jobs and observability, and then a little bit of Q&A. I like to usually do interactive presentations. This is not one of them, but if you do have a question and you want to interrupt me, please feel I'm empowered by me to do so. So let's get into it. So first of all, introductions, real quick. I've been doing Ruby for over 15 years. I stopped counting after 15. Um, Honestly, if it weren't for Ruby, I don't know if I would still be a software developer. Matt talked about like the love for Ruby and the community earlier. It's really what keeps me going. I do love Ruby. Um, I think I would hate my job if it weren't for Ruby. Like honestly, I've tried different things, and I really did give Python and PHP a chance. It just didn't work out for me. Um, so anytime I get a chance to give back to the Ruby community, I'm all for it. So if you're looking for a mentor in Ruby or something like that, please reach out to me. I'd be happy to share my experience with you. I don't know how many of the 15 years are good Ruby experience, but I'll share that with you anyways. I work at PayPal and a sub-org of PayPal called Braintree. PayPal acquired Braintree over a decade ago, I think, if I'm not mistaken. And yeah, to your surprise, PayPal does Ruby. Um, Sharon did a great job introducing us earlier today. So all of that stuff, she already did much better than I do about mobile SDKs and process paper and processing. But if you're familiar with e-com and you want to take credit card transactions from your customers and get paid, well, you'll probably want to use something like Braintree. We give you all the tools that you need, and coupled with PayPal, you get the quick checkout buttons and all that kind of stuff. So obviously, I don't know why I would choose anything else. But yeah, so we have a large Ruby code base at Braintree. It's old. I won't use the L word. Um, and I work on a subgroup of Braintree where we do the merchant processing. So everything that happens after transactions are taken and we move the money. And I'll talk a little bit more about that in a little bit. And we're hiring. We have a booth outside. You probably saw the big PayPal sign. We have a office here in Chicago. There's a bunch of people here from PayPal. Awesome, thank you. That was not rehearsed, so I'm glad. Uh, all right, so come talk to us. We're super friendly, I promise. Maybe not me, but they are. Required sort of disclaimer, all the code that you're going to see today is not production code. It's for illustrative purposes. It's examples, so don't go try to copy paste that into your code right now. But hopefully it will make sense for the examples that I'm trying to show. So let's dig into it. Pipelines, what are pipelines? Well, the reason why we use pipelines is we as a team, we take everything, all of the data that happens throughout the day where merchants are taking credit card transactions and they need to get paid, they need their money. So how do we get them their money? And we are a global processing platform, so we have to do this all over the globe. So we have US customers, Canada customers, European customers, Brazil, Australia, you name it, right? And so each region has its own particulars. Each region has its own different partners and banking partners and all that kind of stuff. So we have to build something that's tailored to all of that, right? And what happens usually, what my team works on is we compile all the payout data every day, that all the amounts that merchants need to get paid. We generate payout instructions that we send to our banking partners. So you can imagine working with banks, that's XML files or PAIN files, which is the spec that some banking partners use. And so we send a file to our banking partner, and our banking partners transfer the money that we send in those instructions and they either tell us everything worked, or they don't tell us anything and we have to guess, or they tell us that something failed and we have to fix that. And so they send us back some files. So we have to do this in every region with every partner, and this is why we have to build like these pipelines of background jobs that work together in some sort of sequence to achieve what we do. And so some of the requirements we have are we need to be able to schedule jobs, right? So we have to have schedulable jobs. Different parts of the day, it depends on the on each job. Jobs have to have dependencies. So we have to have a job that compiles the payout data and another job that creates the file and another job that transfers the file to our banking partners. So these jobs need to be dependent on each other. We need to be able to do retries because shit happens. And that we want that to be one of the baked-in features of our pipeline. And we need to have notifications. We need to know what's going on. We need to be able to send our developers, on-call folks, information about what's going on. And we need some sort of observability. So we need to tag our jobs, track our jobs, have stats about our jobs, et cetera, right? And each region gets its own pipeline. And so all of that, if you put it together, we have what something looks like a pipeline, which is a job that generates a report or consumes a report from our partners, right? So we either generate a report or consume a report. We transmit the report to our partner, or we save the report data to our DB, and then we notify somebody. So if you put that all together, that lends itself to concept of pipelines, right? Which is really a grouping of background jobs that run in succession at a specific time of the day. And if any step in that pipeline fails because of these dependencies, the whole pipeline is halted, right? And so we need to be able to intervene and fix whatever is going wrong so that we can restart or continue the process. So this is why we use pipelines. The how, well, obviously we use Ruby. This is why we're here. We also use Ruby on Rails because Ruby on Rails as a framework gives us a lot of glue to put together. We're talking to a database. Ruby on Rails gives us that layer. We do have some web-based stuff, but that's morely for internal purposes. We do generate certain reports and stuff like that. And one of like the star of the show for us is really the Culist gem. Might have not heard of it, but it's a great gem that we work with, which is similar to Sidekick. This is not I'm not sponsoring any of them. But Culist was the gem that was decided long before I joined. And it has some features that I'll talk about in a second. And so one of the things that really we like about Culist is the dependency management, which I'll show examples of. And it has a good enough admin UI for us to see what's going on. And we write a lot of modules on top of that. So a lot of custom code that we enhance, and I'll show you some examples. All right, so the first thing is, how do we create a job? So it's a very basic example. This is very boilerplate Rails example if you want. A pipeline job for us is a database model. And every time we want to queue a job, we create an instance of it in our database. And we do that so that we can keep track of every job that runs and what metadata is associated with it, so that we are able to retrieve that and figure out what's going on with our system, right? So this is very basic. If you look at it, we're just, what the job type is really a class that we have. It's like a background job class. Then job data is a hash that we save. And then we'll talk a lot about delays and dependencies, and then priorities, and pipeline day are just extra metadata that we have on it. And so every day or every time we run our scheduler, we save this information in our database. So I talked about pipelines. Every pipeline has a schedule service. In that schedule service here, this is an example, pipeline X. We have a few jobs that are being scheduled for the day. So this scheduler uses the method that I showed you before, which we call create job, very simple name, but the code that we showed in the previous slide. we call it here each time so that we say these are the jobs that we want for this pipeline, and this is how it looks like. So assume that there is a job, there's a class called ACH transfer generator and an ACH disbursement job. Those are the classes that are going to get called when we schedule an imputed job, right? So a couple of things here to note. At the very top, you see that we have a no-op job that's being created. This no-op job does what the name says, nothing. And the reason we do this is because we want to start certain jobs at a particular time of the day. And so we use the delay option in QList when we enqueue jobs that lets us enqueue jobs at a specific time with the delay parameter. Now, why don't I just specify that on any job that I want? Well, we have jobs that not only depend on a specific time and need to start after a specific time, but also after a specific job that needs to end first. So that's the third job that we have there. The disbursement job depends on the job that's before it, but also should not start before a specific time. In a contrived example, if you think that maybe somehow the second job started early and finished early, but we don't want the third job to start before 7, now we can specify the two dependencies for the third job, the no-op job, and the generator job. And so this is how we can combine both a delay and a job dependency together into one for one job. And so this is our workaround for being able to do both types of delays based on another job and on a time, right? So now that we have this pipeline scheduler, every day we have a cron job that runs, and that cron job calls the pipeline schedule, creates the job for us, and really it does the following. It checks, is this a business day? Do we need to do anything? Or is it a bank holiday? If it's a business day, it creates the job in our database, and then queues up the job using QList. After the dependencies are met for each job, the job runs. We save the execution. There's obviously a lot more that we do, but for our talk, we'll limit it to this, right? So I talked, the last slide showed the execution is saved. So mentioned a lot of modules. We built a lot of modules to help. Well, one of the modules we have is the execution middleware. In this code here, you can see that really the beauty of Ruby is that everything is extendable, and we can override anything that we want. Obviously, that's dangerous. Don't do it all the time. But in certain cases, like this one, we can override the around perform method that QList gives us, and we can track the start time of the job, the end time, the completion time of the job, and then save that once the job has executed. And this is how we can sort of hook into QList as a gem and then use Ruby to do what we want, to track what we want, right? And so in this method, you just have to assume that we have some basic association between our pipeline job and the pipeline job execution, just regular Rails associations and models over there. So now that we have the setup for how our pipelines are set up and how they're saved and triggered, how do we assure that we have scale? Because at PayPal, we move a lot of money, billions of dollars a day, GTP of like Switzerland, maybe per year or something like that. So scale is important. One of the keys to scale for us is resiliency. Obviously, anything that could go wrong will go wrong. We all know that. So how do we prepare for that? So one of the ways we build resiliency into our pipeline is retries, which I talked about earlier, baked into QList. Idempotence through save points, which I'll show an example of that in a second, and some feature flags. Those are just a small subset of things that you can build, but obviously each app is different, so you can figure out what your app needs. But one of the important things is bake anything that can go wrong into your code, right? Because you know it's going to happen, so bake it into, figure out how you're going to deal with it in an automated way. And so let's show examples. Save points. So talked about idempotent. So obviously retries are baked into QList, so we don't have to write custom code. But there are certain times where idempotency is not easy to achieve through vanilla Ruby. So we have built in a way where we have these things called save points where you can enclose your code with this block. Um, how you implement this is up to you, but for us, it's we have a row in a table that's called a save point with a label. That label is unique. Uh, if our code tries to run the same code again with the same label, and it knows that this save point has already been run before, it doesn't try to run it again. So an example of this is um, assume that we're downloading a file and processing a file that a bank partner gave us. We don't want, if the job fails for whatever reason at some point after we've downloaded the file and that succeeded, we don't want to try to download the file again. Usually it's because after we download the file, we move the file somewhere. And so it's no longer there. So if we try to rerun the job, that job will fail because the file is no longer there. So we know we've already processed the file and we saved it somewhere where we want it in S3, let's say. So we encapsulate that with a save point, and if the job is rerun for any reason, it knows that this particular file, which is unique with this date and some identifier, has already been downloaded, so it doesn't try to rerun that part of the code. So that's one way we build resiliency and into our pipeline. Another way is we know that we're going to get query timeouts because we usually process long files and we save those into our database. And a lot of the times we get these peak days, like holidays, for example, where the file is too big. It doesn't process within the timeout that we've already set for the database connection. It doesn't need to page. We don't need to have manual intervention. We know usually that a retry with a larger timeout actually works. And so we've built that into our code. We automatically retry any query timeouts once with you can set that through metadata on the job if you want more retries, but you can say I want it to be retried once with double timeout. And so we bake that into our code. And if you remember, part of the pipeline scheduler before, we showed that we have these cutoff metrics. Well, the second way we built scale is observability. And it's a tough word for me to say all the time, but I wish there was an easier, shorter word. But you can't diagnose issues if you don't know what's going on with your system. So you have to collect as many metrics as you can. And an example for us here is part of the metadata, which is just a Ruby hash. We can add whatever we want to it. And here we add something called the cutoff at metric, which we say this job needs to be finished by this particular time. Otherwise, we will miss some business deadline. The banks will not be able to process our transfers, something like that. And so we set that metadata on our job. And then we use a middleware. Like I said, we do a lot of middlewares, where we say, okay, if, and you don't have to know this code, but this is just an example. If when the job runs, track the time. If the time exceeds the cutoff metric, track that somewhere. And so we'll get charts like this, where we use Datadog to track our metrics. And so you'll see these are two examples. The top example is all of the jobs that have run for the past X amount of time. They're all in the green, so they all were finished before the cutoff time. And the line just represents the time between when it finished and the cutoff, right? And so the higher the graph, the better. The lower example shows where one of the jobs actually at one point exceeded the cutoff time and finished after the cutoff time. And what we can do is set up paging alerts in Datadog that track these graphs and these metrics and let the on-call folks know if something's gone wrong, right? And so this is how we can build into our pipeline a way for us to know what's going on. It's very important to collect baselines so that we're not doing a lot of false positives and pagings for no reason. But observability is really a key thing for us, that we have a great team that works on this all the time, that they try to improve. Some of the folks are here. I really owe all of this talk to them. Um, and so yeah, so another thing for us, for example, is we want to track when a job has run. And so this is another example of a middleware that you can write to record a job event. And what we do here is we notify. If you remember the graph that I showed earlier, where you run the job and then at the end you want to notify, well, you want to know if your job is running. And the difficult thing about background jobs is they're in the background. So unlike a web request where you're loading a browser, you see what's happening, you get instant feedback. With a background job, you're sitting there hoping that everything's going well. And so for us, it's important that we notify of events of what's going on. And so we have this middleware. Again, this is a contrived example. There's a lot more code that usually goes into it, but you can see the example of, say, all right, we have these events that QList gives us of when a job starts or completes or fails, and then we can notify. In our case, we notify a bunch of systems, for example, Slack, email, whatever you want, right? Datadog, anything like that. And so this is that same thing, but displayed a little bit differently, where you can see that anytime a job starts, we notify Slack. Anytime a job finishes, we notify Slack. And so if you want just a quick view of, hey, what's going on with my system? Are the jobs that are supposed to be running? You can immediately go and search Slack for the job name, and you'll find it, and you'll see the latest instance, if it's been put in the queue, started, not started, etc. And so we have a lot of SLAs in our system, right? We are moving people's money. It's very important that we do it right. So one of the things that we do have is we have a cron job that runs and checks the health of our system on a periodic basis. And we have monitoring code that takes any job that we want to monitor and say, has this job started at a specific time that we expect it to, and has it finished at a specific time that we expect it to? And the way we do that is a simple cron job that calls the health endpoint of our app. And what this endpoint does is, for each job that we're monitoring, gets the list of jobs, checks the expected runtime. We log that in the metrics like we saw before. Is it out of bounds? So easy to check. You compare the time of the job when is it finished? Is it now finished? And when it's supposed to finish? And you compare that basic time math there. And then if it is out of bounds, you alert. And you say, hey, listen, this job is supposed to finish at 10. It hasn't finished. Something's wrong. Go check it out. And this gives our on-call folks the ability to come in and intervene manually if there is any issues that comes up. Which brings us to our last section, our Q&A. I have 5 minutes, so happy to answer any questions that you have. And we already have one over there, and I'll come back to you here. So the question is, if you have checkpoints, what happens if the checkpoint fails, right?
Correct.
And so if the checkpoint fails, it restarts. And so it either finishes and you save that it finished in the database. And so you know if it tries to execute again, you don't. If it failed, you hope that the code that you wrote in there can be restarted. And usually you don't put a lot of code in each checkpoint. You try to split things up in a way that's logical and easy to manage, so that if it does restart, you have the expected outcome. Answers the question? Okay. There was a question here first. The beauty of working for a company like PayPal is we have offices around the globe. And so we have folks who are dedicated to being like first responders to on-call issues, and we have coverage, 24 coverage with the folks around different time zones. If you don't have that, pager duty and loud alarms can help. Since the mic is there, let me go with that, and then I'll come back to you.
Just another question about the specifics of the checkpoint system. Do you keep track of those in perpetuity, or do you delete them once they're completed?
Um, it was a great question for the talk before me about SLAs and time to live. Everything that we have in our database has sort of like a time to live. I don't know, Cooper, if you want to. Yeah, it's a database record, and then some things are icebox or archived, so moved away from our main database or purged if.
Okay, so it's just a combination of like requirements for keeping track of things
Yeah,
versus not having the database just full of year-old jobs.
yeah.
Okay, thank you.
Francisco.
It was my question was actually along the same lines. Like, do you use a specialized database to track all of these things? Because
Postgres.
oh, cool.
It's right. Yeah, I mean all Rails models in Postgres. Yeah. Um, Power of open source. Uh, yeah, I mean that's Scott and Cooper's bane their existence. The white noise. It's a really tough battle to like win. How much noise is good noise or bad and all that kind of stuff. Um, the Slack channel is easy to mute if you don't want to listen to it, and we have layers and like tiers of things that are noisy or less noisy, right? And so there's a channel where everything goes into it. You don't have to listen to it, but if you need to go back, you can. Some of that data is also replicated in Datadog, and there are more metrics and alerts that come out of that. And there is some stuff that actually pages on call or primary or backup on call and stuff like that. And so it really depends on how much like critical it is and how much intervention it requires or how much is automated, right? And so that's really up to you to tweak that to your liking. All the time, all the time. I mean, we have these conversations all the time, but just like Matt said, re-engineering something from scratch doesn't work, and so we keep improving and building on our systems. Obviously, I think there's a Sidekick talk coming up next. Like, would we use QList versus Sidekick or any other technology? Like, there's always these conversations that we have to do. I don't have anything like worth talking about in the next 10 seconds, but it's like there's always tweaks that we're doing, always.
With the save points, with jobs that you want to run multiple times, but maybe not like very close together, how are you scoping those save points so that you can like pay the same person two times, but you're not doing the same transaction?
Yeah, so we don't pay the same person 2 times a day.
Oh, sure, yeah.
So that's one of the ways we solve that. But everything has a unique key. So usually, for example, when we're running something for the day, there's there's a model that has a unique identifier that is generated, and that can go in as part of the label for the save point. And so you always know that if you're trying to run the same job multiple, because we have a lot of jobs that we run multiple times because we don't want to reinvalidate ourselves and all that kind of stuff. But there's something unique. So if that job runs, like I don't know, I'm trying to think of something that's easy to say. But for example, the pipeline is part of the label, right? And so if running it in EU versus US, the pipeline is part of the label. So that you know that this job can run multiple times, one for this pipeline, one for that one, right? Stuff like that that can help. There are more questions.
I can take one more question and keep things on time.
Okay. So we do rely on like Datadog quite heavily, for example, and not to like not don't mean to endorse them or plug them, but it is one of the tools that we do rely on. There's there's plenty of tools that are out there that are very helpful and good to use. All right. Disclaimer again: all the code snippets were examples. Um, I did generate the snippets images using this website if you're interested. And reminder, we are hiring. Come see us at the PayPal booth right next door. And thank you so much.